As we study the physical nature of the universe, we discovered that there are particular numbers that enter our equations. For example, the equation E is equals to mc square includes the number c is equals to 299792458, which is the speed of light. Other examples are the gravitational constant in F is equals to minus gmm by r square, or the charge of the electron or the mass of the electron. In particle physics, we have a theory called the Standard Model that describes the physics of atomic particles. The Standard Model is the central understanding that we have of physics at very small distances inside of protons. The Standard Model requires 19 numbers or parameters to be fed into it before it works. These are numbers like the charge of electron, physical constants. It is central to special relativity that physical constants, as with all laws of physics, are the same regardless of the direction in which the measuring apparatus points in space-time. That is, regardless of the velocity of the measuring apparatus. The invariance of the physical constant, that is the speed of light, is often associated with special relativity, but the invariance of all such physical constants is included in special relativity. Theoretical physicists often set Planck's constant and the speed of light equal to unity, that h cut equals to c equals to 1. The mass dimensions of these constants are dimension of c is equals to L upon T, dimension of h cut is equals to m L square upon T. If the physical constants are to be unity, then time t must be the same stuff as length L. The mass m must be the inverse of length L inverse. That is, dimension of t is equals to dimension of L, dimension of m is equals to 1 upon dimension of L. Physically, m inverse is the Compton wavelength of a particle of mass m as well as length. We need a mass dimension for electric charge, dimension of c. It might be that physical constants come directly from mathematics. There are special numbers in mathematics. The number pi is equals to 3.1415 ... is one such number. Another such number, and a more important one, is exponential. E is equals to 2.71828. It might be that we will eventually have a theory of everything that starts with no more than the proposition that numbers exist, and from this we can calculate the physical constants of nature as special numbers like pi or e or sine of sine 1. If the physical constants are from special numbers within mathematics, we are now no closer to understanding this or knowing where to find those numbers than we were. It might be that the values of the physical constants are from initial conditions at the start of the universe. Perhaps they were set when the Big Bang occurred 13.8 billion years ago and have remained unchanged since then. If this is so, it is unlikely that any theory we develop will enable us to calculate the values of the physical constants and the theory of everything, which will be theory of almost everything. Space and time are not separate entities but are joined together into a single space-time. If space-time is one entity, then time must be the same stuff as space, even though the two things appear to be different to we humans. We say that the mass dimensions of space and time are the same. We write this as dimension of t is equals to dimension of L. What we are saying here is that if space is measured in meters, then time must be measured in meters. Alternately, if time is measured in seconds, then space must be measured in seconds. Instead of saying that the sun is 93 million times miles from Earth, we say that sun is 8 seconds from earth. Consequence of this is that the mass dimension of velocity is just a number, that is the dimension of velocity is equals to dimension of space over dimension of time, that is meters over meters, that is seconds over seconds is equals to 1. It is normal in theoretical physics to set the velocity of light, which being a velocity is just a number equal to unity or 1. They do this because it is easier to put c is equals to 1 in formulate and then not worry about factors of c. The factors of c are easily recovered when needed. Such units with c equals to 1 are sometimes called geometrical units of relativists. The concept of mass dimension appears almost everywhere in theoretical physics. The equivalence of space and time is the basis of this concept of mass dimension.